Hello all, we are Team Inception. This is a presentation video for ML1 Final Project. Our project is a restaurant recommendation system. Due to the sheer amount of information available on the internet, users feel overwhelmed with the number of options available. To deal with this problem, websites have a recommendation systems, which simplifies decision-making on users' part by showing options users might like based on their purchase history. Recommendation systems play a very important role in websites like YouTube, Amazon, Spotify, and most of their revenue is driven by it. Our main goal from this project is to construct a recommender system utilizing Yelp dataset that can predict users' preference using users and businesses' information. Specifically, the model aims to learn and recommend few options to users. Our project is divided in 3 parts. First, it's getting data ready, where we have a first look at the data set and do some basic null handling and typecasting. Second, it's an exploratory data analysis, where we look at various plots and gain a deeper understanding of data. Finally, we have a modeling part where we make a baseline recommendation model and try improving on it by using neural networks. Yelp has an open data set. It provides a rich collection of data about businesses, users, reviews, ratings, and other types of information, such as tips as well. All these are separate JSON files in a data, and we worked with 3 of these JSON files. Reviews JSON, whose each record is a rating and a full text review that a user gives to a business on a certain date time. Another one is the business JSON, has a business profiles with the location data, attributes, and categories. And finally, we have the user JSON, which has a user profile, including the user's friend mapping and all the metadata associated with the user. When we were working with the data, the kernel crashed many times as the data size was too much for RAM. Our solution to this problem was creating a SQLite database and querying data as needed, hence reducing overhead on RAM. Our database had 3 tables: users, businesses, and reviews, which were exported to database from corresponding JSON file. Jameel, you have the floor.
Thanks, Aziza. So after creating the database, we started with the exploratory data analysis. When we see at the number of reviews given by the year, we see that the number grows exponentially. This could also be an evidence for the Yelp's popularity over the years. In the next slide, we go over reviews by hour. This plot has number of reviews faceted by hour of time. This is interesting as we see minimum number of reviews were given during the morning, and the count keeps rising throughout the day, which seems intuitive. But maximum number of reviews were given at 2 a.m., which is counterintuitive. Why are people reviewing this late? Is it possible that these are bars where people stay for long, but why would drunk care for reviewing? Or are people reviewing after dinner during their commute home? We would have to look at further evidence to draw conclusions. In the next plot, we looked at the map. When we plotted the restaurant locations on a US map, we observed that the restaurants and the data are clustered around certain metropolitan areas. Like the blob near Phoenix on the left side of the slide is Las Vegas, and our data had a majority business from Las Vegas. In the next slide, we looked at the top 5-star ratings. When we looked at restaurants with multiple branches by grouping them by name and taking average of those with count greater than 1, we see that Starbucks has the highest average rating. In the next slide for findings, after looking at a lot of faceted plots, we conclude that restaurants with features like takeout, accept credit card, good for kids, reservation, good for groups, business parking, has TV, alcohol, bike parking, delivery, outdoor seating, Wi-Fi, ambiance, dogs allowed, good for dancing, coat check, counter service, attire are more popular than their counterparts. So if you're starting a new restaurant in this region, make sure your restaurant has most of the listed attributes. Now Yashraj will go over the next set of slides.
So now the fun part, the recommendation system based on collaborative filtering. Collaborative filtering produces a recommender system that recommends restaurants based on similar attributes and characteristics of user. Hence, the method relies on the assumption that users similar to each other have same taste, so they like similar items. Our implementation creates an embedding for every user and restaurant in a L-dimensional space. Every number in embedding vector that describes some property of user or restaurant. It collects all the properties of different items and uses them for recommendation. In order to learn these embeddings, we use a neural network which minimizes MSE on train set. We wrote two different recommendation systems. First, the linear model and the non-linear model. In the linear model, we use dot product of embeddings and add user and restaurant bias before putting through sigmoid. In the non-linear model, we use combination of embeddings by stacking them together and passing through a feed-forward neural network and then add user and restaurant bias before putting them through sigmoid. Iniyan.
Yeah, now we can look after the deployment. So we also tried a simpler deployment of our nonlinear model. We wrote a recommend function that takes user ID as input and returns a data frame of restaurant users should try. Cool, right? This happens in 3 stages: candidate generation, ranking candidates, and predict using user rating. Our recommendation system is very large in size, so we won't put all restaurant at once for one user. This would result in slow recommendation. We use candidate generation, which looks at a user's history, infers our location, finds best restaurant in our location, and also looks at our friends' favorite restaurants. These restaurants are now candidates that user might like. This candidate now go through our model, which ranks them according to predicted rating. Next, we see model in action. Here we see personalized recommendation for user with ID 66 and 79. Next, we can see comparing models. We use average model as a baseline. Linear model fails to beat average model. We strongly suspect that this is due to insufficient training, while non-linear model beats both linear and average model. Next, we can see improvements. We can further improve this project by training model more to improve performance. We also improve candidate generation by adding explicit arguments for city and restaurant type. So user will be able to customize options returned. Next, we can see the conclusions. We had a lot of fun working on this project. We got a chance to practice all skills taught in ML1. We explored data and also beat baseline model. By this, we are concluding our presentation. Thanks. Have a great day.